everyone, I'm Sidhvita, a member of Krino Forensics. Before starting this video, let me ask you a simple question. Have you ever thought that something common as paint can actually solve a crime? Yes, even a tiny paint chip can act as a crucial forensic evidence. So in today's session, we are going to explore paint as a forensic evidence in very clear and structured way. Paint is one of the most commonly encountered trace evidence in forensic investigations. It is found almost everywhere on vehicles, buildings, tools, and objects. Because of this widespread presence, paint becomes extremely valuable in linking suspects, victims, and crime scenes. Now, before understanding its forensic role, let's first understand what exactly paint is. Paint is a liquid mixture that applied to a surface which later dries to form a solid coating. It serves both protective and decorative purposes. For example, it protects surfaces from moisture, chemicals, and environmental damage, and also enhances appearance. One very important function of paint is corrosion protection. Now, since paint is present on almost every surface, it easily transfers during contact, making it an important source of trace evidence. Now, let's look at how it can exist in different forms. Paint can be applied in three forms: solid, aerosol, and liquid. Now, coming to its functions, it acts as a protective coating, provides UV protection, enhances decorative appearances, and prevents corrosion. So, clearly, paint is not just aesthetic, it has multiple functional roles. Now, to understand how paint behaves as an evidence, we must first understand its composition. Paint is a complex mixture made of several components. This includes pigments, binders, solvents, additives, and fillers. Each component contributes to physical and chemical portion of paint. And this unique combination is what helps forensic scientists to identify and compare paint samples. Now let's discuss each component one by one, starting with pigments. Pigments are solid particles responsible for the color and opacity of paint. They also help in protecting the surface from UV radiation. Pigments can change the appearance of paint, increases hardness, and decreases ductility. They may be natural, synthetic, or organic or inorganic. Some common pigments include zinc oxide, zinc yellow, iron oxide, etc. Now, after pigments, the next important component is the binder. Binders, also known as resins, are the substances that hold all the components together. They form a film when the paint dries and helps it adhere to the surface. Binders provides durability, weather resistance, and gloss. There are two main types: convertible binders, which undergo chemical changes after application, and non convertible binders, which are already polymerized. Now, let's see what makes it easy to apply. Solvents. Solvents acts as a medium which pigments and binders are dispersed. They control the viscosity of paint, making it suitable for brushing, rolling, or spraying. After application, solvents evaporate, leaving behind a solid coating. Common solvents include water, white spirit, xylene, toluene, and alcohols. Now, apart from these major components, there are some minor but very important substances called additives. Additives are added in small amounts but have significant impact on paint properties. For example, dryers accelerate drying, plasticizers increase flexibility, biocides prevent microbial growth, and UV stabilizers provide resistance to sunlight. So, even though they are present in small quantities, they enhance overall performance of paint. Now, let's see how paints are classified. Paints can be classified based on their application. This includes architectural paints used in buildings, automotive paints used in vehicles, industrial paints used in machinery, artistic paints, and specialty paints like marine or aerospace coatings. Among these, automotive paints are extremely important in forensic investigations. So, let's understand them in detail. Automotive paints consist of multiple layers. These includes electrocoat primer, primer surfacer, base coat, and clear coat. Each layer has specific functions such as corrosion resistance, smoothness, color, and protection. This layer structure is unique and plays a major role in forensic comparison. Now let's move to the forensic importance of paint evidence. Paint evidence is commonly encountered in cases such as hit and run accidents, burglaries, and vandalism. Paint can transfer from one surface to another during contact. For example, in a vehicle collision, paint from one car may transfer to another. Each paint has unique chemical composition, which helps in identifying its source. So, paint acts as associative evidence linking to objects and individuals. Now, once paint evidence is found, it must be collected properly. Collection of paint evidence must be done carefully. If possible, the entire object should be collected. Paint chips should be kept intact to preserve all the layers. They should be stored in a paper folds, envelopes, or small containers. Reference samples should be collected from nearby areas, and most importantly, each sample must be packed separately and properly labeled. Now, after collection, the next step is comparison. Comparison of paint evidence helps in determining its origin. In automotive paints, the sequence of layers is compared. If the layers match exactly, it strongly suggests a common source. This makes paint comparison a very powerful forensic tool. Now, let's understand the overall workflow of paint examination. The forensic examination of paint follows a systematic process. First is collection and preservation, then preliminary analysis, followed by chemical testing, and finally instrumental analysis. Each step provides more detailed information about the sample. Now let's look at different examination techniques. In microscopic examination, we perform a visual inspection. We observe color, texture, gloss, size, and shape. Stereo microscopy is used to examine the layer structure and edges. This step helps in initial screening and identifying obvious matches. Now, if more detail is needed, we move to microscopic examination. Microscopic examination provides detailed analysis of paint layers. Techniques like polarized light microscopy help to study pigment distribution and optical properties. Scanning electron microscopy provides high resolution of images. This helps to identify the number of layers and the thickness. Now, along with this, another very strong method is physical matching. Physical matching involves fitting paint chips together like puzzle pieces. If the edges matches perfectly, it proves a common origin beyond doubt. This considered one of the strongest form of evidence in paint analysis. Now let's move to chemical testing methods. Solubility test helps to identify the type of binder. Different solvents are applied to observe reactions. For example, acetone dissolves acrylic paints, chloroform dissolves nitrocellulose, and water affects latex paints. This helps in preliminary classification of paint samples. Now, for more detailed analysis, microchemical tests are used. Microchemical analysis helps to identify pigments, binders, and additives. Techniques include spot tests, pyrolysis, and chemical reactions. These tests help to detect elements like lead or chromium. This provides a chemical profile of the paint. Now, for the most advanced level of analysis, we use instrumental techniques. Instrumental analysis provides a detailed chemical fingerprint of paint. Techniques include FTIR, Raman spectroscopy, XRF, SEM-EDS. These methods help to identify both organic and inorganic components with high accuracy. These are essential for defining comparison. Now, finally, let's understand forensic significance of paint evidence. Paint evidence is highly valuable because it transfers easily during contact, it has unique composition, it is durable and persistent, and it helps to link suspects to crime scene. It also helps to reconstruct events by analyzing layers, so even a tiny paint chip can provide a powerful evidence. So to conclude, paint may seem ordinary, but in forensic science it becomes extraordinary evidence. It silently carries information about contact, transfer, and origin. As a forensic scientist, our role is to carefully analyze these tiny traces and let science reveal the truth. Thank you for watching. I hope you find it informative and useful. In case if you have any doubts or want us to explain any forensic topics, please comment below. So we will cover them in future forensic videos, and the presentation document will be shared on our social media channels. You can access it from there. Stay tuned to learn with Krino Forensics to explore the world of forensic science. Thank you.